So it will be recorded here. So I'll share it with the video.
Okay, sir.
So first, what is that question? You have to find out the elasticity, no?
Yeah.
Okay. So let me draw to. This one is 1, and then another one is a little bit this way. Okay, this is not parallel. Okay. Now, okay. So now there is P and Q. This is Q and this is P. This is CA. This is O. The upper one is C. This is A. This one B. This one D. And this one is E1. This one is E2. So the question is, you have to find out the elasticity at point E1 and E2. Just follow this one, okay? You will get the video. I will share you in the WhatsApp.
Okay, sir.
So E1 and E2, what is the definition of elasticity?
Percentage
EP?
change in
Percentage change in
Q over
Q by percentage change in price. Or in equation format,
delta Q by Q into 100
P by Q into del Q
by delta.
by del P. There will be a negative sign. Why this is happening? Because
P and Q.
there is inverse relationship.
Okay.
Between P and Q. Means when P is rising, Q will fall. When Q will rise, P fall.
Yes.
So that means this change will be always negative ratio.
Okay, sir. Yes.
You got it?
Yes, sir.
That I explained in the classroom. So now, if you want to find out the elasticity, there is another law along with that. What is that law? Find out the elasticity in a straight line demand curve. At any point of a straight line demand curve. What is that definition? EP is equal to lower segment by upper segment. Okay. So now lower segment by upper segment.
Yes.
So here what is lower segment? This part is lower segment. So if I, this part is the lower segment, this part is the upper segment, lower segment, this is upper segment.
Yes.
So for this one, this will be the lower segment and this will be the upper segment. So elasticity E1 point, so EP at point E1 will be equals to lower segment by upper segment equals to
E1B by
E1B by E1A. Same way EP at E2 will be
E2D by E2C.
E2C. So now in this question it is written that you have to compare these two elasticity.
Yes.
Compare means that elasticity at E1 it's greater than or less than
Yes.
or equals to. In these are the three cases. It's possible here. If it is equal to, or in these two cases altogether you can write not is equal to. So EP at U1 is not is equal to EP at E2. When not is equal to means either it will be greater than or less than,
Yes.
or it will be is equal to, equals to each other. That is my question. So at least we understood that what is the question.
So is it necessary we need to write if it's greater than or lesser than, or is it okay if we just write not equal?
We'll start from somewhere.
Okay.
We'll see, we'll check that how much we can see. Like initially we'll start with the, is there a, like the elasticity at both the points E1 and E2 are equal to each other. If it is not, then we'll try to dig into deeper, that is greater than or less than.
Yes.
What is the actual scenario.
Yes.
So by graphically we can see that these are the two things I am getting.
Yes, sir.
E1B by E1A, E2D by E2C. This part of the straight lines are not related to each other. How can you compare? In OpenEye, you cannot say that E2D is greater than E2B. Can you say that?
No, because E2 is not connected to B.
See, here on blue line. So if I draw it's not visible, purple. So if I draw exactly a vertical line and that directly cut your horizontal axis, so it will create a right angle triangle.
Yes.
So if I draw a right angle triangle, so let's take another page. Okay, suppose
It's being recorded.
suppose this is my triangle. Okay, this one is 90 degree. So here, okay, I am not familiar with this one. I usually use this one for reading purpose only, but it has lot of characteristics. So this is 90 degree. Which angle will be greater?
This one.
This
Right.
one. So theta 1 and theta 2. Theta 1 will be greater than theta 2. Suppose this is A, B and C. So AB and AC. Which one will be greater?
Angle?
No.
Length.
AB or length?
AC.
AC will be greater.
Yes. So,
Now go back to our previous figure. Which one? Theta 1 and theta 2. Which one is bigger?
theta 1. Theta 1. Theta 1 Theta is 1. bigger.
Theta 1 is bigger than theta 2.
Sir, but this is, since A and C does not coincide, we can't say exactly whether theta 1 is greater than theta 2.
Okay.
Can't prove it.
So how can you do that? You just have to extend the line. Okay, I'll take.
Oh.
Or like for perfect photo, perfect figure, I can draw a perfect figure just like that.
Okay.
Now it's visible.
Yes.
Now you can say that
Theta 1.
the theta 1 is greater than theta 2.
Theta 2.
But you have to, like, there are more than 5-6 types of proof is there. I gave you the general sense, general knowledge. Looking into the only the figure, you have to understand that what is happening here. So theta 1 is greater than theta 2.
Yes.
So if theta 1 is theta 2 greater than theta 2, that means
Oh,
E2D will be greater than E1B.
yes. Yes, sir. Because,
Exactly what you say in that figure.
yeah, understood.
This part will be greater than this part. Same thing I am saying that E2D, this part will be greater than E1B. Now look here, this one is E1B and this one is E2D. Which one is greater?
E2D.
E2D. So in this case means at E2 already the numerator is greater than.
Yes, sir.
So numerator and denominator, this one is always greater, we already found it out. Now the second part is coming here. If numerator is greater, that means it gives us a proper idea that okay, this elasticity is supposed to be greater.
Okay.
Now you have to look into the denominator. If denominator of this one is larger,
Then,
then there is another problem.
yeah.
You find out the problem. Means if I extend this line, so here this part is larger than this part and this part will be larger than
That part.
this part. So both numerator and denominator is greater for this case,
Okay.
and for this case numerator and denominator both are lower. So obviously what will be the impact in the ratio, we have no idea.
Elasticity will be,
Elasticity lower segment by upper segment, no?
yeah. So,
That means I am saying that
oh yeah, it will
Yeah.
cancel out.
yeah, E2 cases, so E2 by D by E2 C and E2 E1 E1A E1B according to the figure. This is A, this is C. Okay, here we find out that E2D is greater than E1B. The same way
E2,
E2C is greater than E1A.
yeah, so,
So both are greater than. So if like that, suppose I am drawing to, I am giving an example of a ratio. Okay, suppose this one is 2 by 4. Okay, and then there is a ratio of 4 by 8.
yeah,
Here the numerator is greater and denominator is also greater.
correct, yes. So it means the same thing.
What will happen in the ratio? We have no idea. How much greater and all those things you have to consider.
Yes.
So maybe it will be equal or maybe it's not equal. All lower or greater, whatever the things is, we have no idea
Yes.
about the ratio here. So whatever process I followed, that is not giving me a proper result. Even it's not showing that it will be equal or not equal. Just looking into this phenomena, I cannot say that EE1 is equal to E of E2 or not.
Yes.
Okay, so I have no idea. So this process will not going to help me. So I have to find out another process. What I am trying to say, how you solve a problem.
So should we show this process?
No need.
Okay. Yes, sir.
So
Well,
this
if
is
you
the
show it,
see.
it's-
This is the thing. When you look at the thing, you will get it. You don't have to derive all those things. Just looking into that figure, you have to understand that part.
Okay. Yes, sir.
Means you have
And
to
draw a
make
rough
your
figure.
brain. You have to do it in your brain. You have to make your brain a little bit liquid, because the students who come up with a proper solution, some students already did it. They got 5 on 5.
Yes.
Excellently they did it. How they able to do it? They try 2-3 methods and then come up with a proper method. So now I need some middleman. So this process I am not able to get it.
Yes.
So I need a middleman. From there I'll get actual a scenario. See here, these two graph, okay, can it be comparable to this point, this line?
Yes.
Sir, can you repeat it?
Can this and this point be comparable to this line?
This line?
We can draw a line through it.
I mean, should we take the formula P by Q into dP by dQ there? P value differs. Sorry, P naught value is same and
See,
Q
the
value.
triangle, from the triangle point of view, ठीक है, in that case the similar type of triangle, if you take the ratio of the similar what
Sides.
similar sides, that will be equal to each other. So can we use that law here?
We
I
can.
This is the perpendicular is equal and the
So, but
side which
these
is
two are
opposite to
not
the right
connected,
angle.
right? They're not the
No,
same.
no similarity between the triangles.
Oh, achha,
And the perpendicular is equal and the side which is opposite to the right angle, this is larger than that one. So even this one is larger than this one. This base of this triangle will be larger than this base.
That just means that this line is larger, and the upper segment and lower segment is larger again. So it's the same thing.
So if we take the formula dP by dQ into dQ by dP into P by Q, so dQ by dP is